Okay, we're going to be talking about 8.3 vector from Savitch book C++ for edition 10. So we're going to talk about vectors. Okay, so vectors are just like array, and one of the issues that we had with the array was we had to know the size of it before we start using it, before we start using the program. Arrays can shrink and grow as needed, but because these things happen in the runtime, it's going to be a little slower than arrays. Arrays are going to be more efficient if we know exactly the size and we don't have to move it around. So we have to see where we're going to have exact size, then we use array. And if we don't, then we can use vectors. Nowadays, with the computers that we have, the slowness is not that much that we worry about it. So that can be a viable part to use instead of the arrays, but each one of them has their own space. So we need to have a base type. So what data type they have. So in this case, we are having int. This brackets over here is called template. So hopefully in your future courses, you're going to be learning about templates and what are they and how does it work. Basically, it says that you can put any data type here, including classes. So I can put a vector inside a vector inside a vector. So, or you can put a string over here or some other data types. So in here, I'm creating a vector of type int. So we can put a string in there if we are doing a string, character, double, or some other ones. So just like array, we're starting with 0. So the first one is going to be 0. And we're going to be addressing them bracket, just like we were doing with arrays. So we can display them by using a square bracket. There is a function. Remember, vector is a class. So with the class, remember we talked about this, that you can have some member function, meaning that when you're creating the vector as an object of a vector class, there's going to be some functions available to you that you can use. And we're using it with the dot operator as a member function. So the pushback is one of them. The pushback, whatever you put it in function pushback, is going to push it at the end of your vector. Whatever you have is going to be at the end of your vector, is going to push it back in there. So let's go over some of the things with the vector. So in this case, we are creating a vector of double with sample. And then we're going to put a 0.0 in there. That's going to be my first element. Then we're going to push back 1.1. That's going to be my second element. Then we're going to put 2.2. That's going to be my third element, using pushback to put the stuff in there. We have a member function for size that's going to tell me how many elements do I have in my vector. So because it is shrinking and growing as needed, by just using the size, I am going to be sure that I'm not going to fall off on one end of it. We can potentially do that, but because we have the size member function, then we can watch it. So when we're creating a vector for the first time, this is an empty vector. It doesn't have anything in it. So if I call the size on it, it's going to give me a 0. The size of this is going to be 0. Now I'm going to do a pushback. Then my size is going to go up to 1. Then I'm going to do another pushback. Then the size is going to go to 2. I'm going to do another pushback. My size is 3. And that's the 3 elements that I have in it. We can use that. We can use that inside a for loop to be sure we are not going to fall off. And remember, because we are using dot size, if my vector grow and shrink, it doesn't matter. This for loop is going to comply with it. So if I have 10 elements, 2 elements, or 10,000 elements, doesn't matter. It's going to work because I'm using dot size member function to go through my for loop. So the way that has been constructed, the for loop here is using the unsigned int. Sometimes some compiler is going to complain if you don't put unsigned and you just use the int for it. So as C++ has been growing and doing things, the idea of having unsigned int, let me go over that. So if I'm looking at the 16-bit int, that was early computers, don't want to make it too big, huge thing. So we're going to have some zeros and ones in there. And the last digit, because we are going this way, that one, if it's going to be signed, if I have a 0 in there, it's going to be a positive number. If I have 1 in there, it's going to be a negative number. So that's the regular integer. So this last one is reserved for sign. That's going to be using it for sign. So it's not going to be used as part of the number. But if we use it as an unsigned, this last bit is going to be part of my number. So 0 and 1 doesn't make it positive or negative. It's just going to be part of the number. So you can think about it that this one wouldn't have. So when it's unsigned, that means it's not going to read this for a sign. So I can use the constructor. We talked about it in the string one. So as a constructor, you can put a number here. This one is going to create 10 elements, and it does initialize it automatically. So we can go through it and access it to the bracket. So this is my size 10 from 0 to 9, and it's all initialized to 0. That's what happens when we say vector int v10. Now, if I do a pushback, remember, my size already is 10. I already have zeros in it. My pushback is going to push back 25 at the end of this, and it's going to increase the size. So my size is going to be 11, and my 25 is going to be the last one. This is the most common mistake that we do, that we create 10 elements, and we want to put it in the first one. By mistake, we're going to use pushback. Pushback always going to put it at the end, and if you create a 10 element, you're still going to put it at the end of it. Okay, so there is an example over here for that practicing that one. So it's just basically what we're going to do with the pushback. So we are reading the numbers from the user, and as far as the number is a positive, we're going to put it in the vector. And as soon as the user puts a negative number or 0, it's going to stop. So it can grow as much as the user is going to put the number in it. And then we're going to use a for loop, and we're going to display what we have in. So we can use the square bracket to access every element in vector, just like C, just like array. If you go outside of your range, C++ is not going to check it. So we have to be sure we are going to be inside the range that we have. So as we're using the pushback, it's going to add the elements to the end of the vector. we went through this. I don't know why it went back, but we're gonna go through. Okay, this is the place we want it to be. All right. So we need the pound include vector to be able to use the vectors. We have member functions in there. We do need the namespace std to use the vector. So what kind of issues we're going to have? One of them is when you're using the square bracket, you can potentially go outside of it. You're going to be sure you are not going outside of the size. We can have the assignment operator for a vector to be equal to another vector. It's going to copy each element from the right one to the left one. Okay, so how does this happen? When you are doing the pushback, you have a size for your vector. But when you push back another element, what it's going to do is going to go in the memory and find some space. And this is happening in a runtime to add to your vector. But they have figured out, instead of just going and get one and next time get one, it's more efficient to get a lot more and reserve it in the memory. So they don't have to look for, remember, every time you do a pushback and you are out of the space, they have to go in the memory, look for a space and connect it to where you are right now. So the way they fix this, or at least comply with it, is to, so if I have, so when it's running out of space, it's going to add capacity. That means that so if I had a size vector of 100 and I have 100 elements in it, that's from 0 to 99 is filled up, and I do a pushback in there, what's going to happen, my capacity is going to go to 200. It's going to get this 100 and it's going to add another 100. In the memory, I have 200 locations, but the size of my array is 101. So the size is the elements that I have. The capacity is how much room am I reserving in the memory. Now, it's going to come into some time that says, you know what, I know I'm not going to go to 200 elements. I know it's going to be only another 5 or 10. So we can utilize that by the word reserve. So I can say reserve certain number if I know exactly how far I want to go, or I can say reserve the size plus 10. So in that case, with 100, instead of doing a reserve of another 100, which would give us 200, we can go with 110 because we know we are not going to go any further than that. So if we know that, we can do it. So we have the reserve for the memory. We have a resize. So resize is going to shrink our vector to that number. That means what? The rest of it is going to go away. You cannot retrieve it. It's going to be gone. So if I have 100 elements in my vector and I do a resize 24, everything after 24 is gone. It's just gone. So that was a brief discussion on a vector. We're going to be working on it for the final project. And I want you to take a look at these things, and we're going to have this activity up, and then you can respond to that. And hopefully we can have some time to talk about it in the class.